everyone. I'm also going to be speaking in English. My German is not quite good enough to be able to do this in German. I did learn how to say Fachverband Pflanzenkohle, which took me a while. But yeah, thanks for for having me and organizing this. It's great to see so many people here, and also exciting to be talking about anything but wood. In my presentation today, I'm going to be focusing on rice. So yeah, anything but wood. A very interesting feedstock for biochar production are agricultural residues. And more specifically, because these type of feedstocks can be combined in like one specific location. So specifically, if you think about agricultural produce that needs to be processed before being sold, so any food products that need to be are in shells that need to be removed, these are quite interesting feedstock because they're generally concentrated in one location where they're processed in a mill, for instance. And so these types of residues, so you can think of like nuts or coffee, like Claudia mentioned, or even cocoa or rice, which is what I'm going to be talking about today. And what I'm going to be discussing is how you can turn a waste product into a valuable product, and also make a climate positive result out of it, and also generate carbon removal credits. Not friends with this, okay. So briefly what I'm going to be talking about today in my presentation. So first, a brief overview of the opportunity of the rice sector, and how to make biochar from it. Also quickly look at the effect of rice husk biochar on soil and greenhouse gas emissions. And then finally, also going to be discussing the opportunity of carbon removal credits, making the farm profitability higher, thanks to the use of biochar as well. So rice is like the staple food for half of the world's population. So there's a huge production of rice around the world. Around 90% of the world's rice production is in Southeast Asia, as you can see there in dark blue. And rice production generates two types of residues, so the rice straw and rice husks. The straw is generally removed at the farm level and left there, but the husk is generally removed at the mill, in large mills, where the husks are concentrated and usually pile up, and at best they're burnt or used to generate electricity. So I mean, making biochar from rice husks is nothing new. It's something that, especially in Southeast Asia, as you can see here on the left, there is tradition of making biochar at the farm level in very kind of artisanal piles, as you can see there, making biochar of, the quality of it is maybe quite variable, but traditionally this is what farmers used to do. But now that rice production is more industrialized and the processing is centralized, you end up with situations like you see on the right. These are two pictures from rice mills. The one on the top is a rice mill in Africa. The other one is in Southeast Asia, in Cambodia. And as you can see, there's just literally piles of husks just there, usually not really being utilized. And the picture below is actually the situation at the mill when the rice husks are being used. Like this is one a project that I will be talking about later, where they do make rice husk biochar, and before using the husks, it was literally just coming out of the factory like in huge piles as well. And currently in the base case scenario, these husks are collected and turned, just used for gasification or electricity generation. But there is a great opportunity to actually make biochar from these husks. Like I said, there's like really large volumes of husks available in a centralized location, so ideal feedstock for biochar production. And you can use different types of pyrolysis equipment to make it. So the one here on the right, for instance, is quite a small scale unit that was actually developed in Switzerland in Ökozentrum. The idea with this one is to provide like smaller units for instance, like farmer cooperatives. They can have a small unit, make biochar themselves, use the heat. I think in this instance, or like, for instance, for like in coffee production, you can use the heat, or you can also generate electricity. And in terms of yield, again, depends on the processing parameters used to make the biochar, but you can yield about 40% biochar from the rice husks. And the biochar itself also has a carbon negative potential, as in it can remove around 1.5 tons of CO2 on average. Again, depends on the quality of the biochar. So removing 1 ton of CO2 equivalent per ton of biochar, so there's an opportunity there to like use this biochar to remove carbon from the atmosphere and also generate credits from it. Rice husk biochar actually also has interesting properties that some of them are quite specific to biochar, to rice husk biochar. So for instance, it has a silicate, so it's around 20% silica, which can help make plants grow stronger and also make them more resistant to environmental stresses and pests as well. Also, biochar with non-woody biomass often has a higher cation exchange capacity, which for soil like increases the potential of soil for like the natural nutrient cycles to happen. So just improving soil health, which in turn also increases crop yields. So again, different studies have different results, like again, Claudia mentioned earlier and showed, but there can be yield increases up to like, 50% or like doubling yields depending on the soils and the crops used. Another interesting thing that happens with biochar when it's used for rice cultivation is that methane emissions can be reduced up to 50%. So as you all probably know, when you're growing rice, it's in flooded fields, meaning that there's very little aeration or air going through the soil. So you end up with anaerobic conditions, meaning that bacteria or like microorganisms that generate methane and consume methane are present. So rice cultivation has methane emissions generally and sometimes can be quite high. And by using rice husk biochar, the methanotrophic bacteria are favored over the methanogenic bacteria. Don't want to get too technical, but this means that the bacteria that consume methane are favored over the ones that produce methane. And so overall, the balance means that by using biochar in rice cultivation, you can decrease methane emissions by more than 50%, which is also like super interesting beyond the carbon removal potential of the biochar itself. Another important and interesting fact is the carbon content of the biochar, which is with rice husk lower than with woody materials, but still has a low H2 organic carbon content, which, as we've been shown this morning, is a good indicator of the stability and the durability of the biochar in soil. So that means that this biochar is quite stable, and again, is a good good candidate for carbon removal. Yeah, so rice husk biochar is great. And the opportunity, and why I keep going on about carbon removal and carbon removal credits, is that these credits are actually very interesting for farmers, especially so in rice production, for instance. Often the farmers see very little of the benefit or the price that we actually pay for the rice. Sometimes they see as little as 4% of the final price is actually what the farmer does receive. So by using biochar, these farmers can first increase their yields, and also if they get the benefits of carbon removal credits, it can overall increase the farm profitability and make the whole thing more viable for farmers. And everything I'm saying now is not just theory. So there's I just want to give a quick case study of HUSK in Cambodia, for instance. It's a company in Cambodia that does exactly what I've been explaining. So they take rice husks from rice mills in different locations of Cambodia, transform it into biochar, and make soil amendment products for farmers. So either biochar on its own, or mixing the biochar with compost or with nutrients as a ready-to-use product that then farmers can use to grow crops. And actually, they've found across different field trials with different crops and over several years that on average, by using these biochar-based products, farmers get on average a 25% yield decrease. This is generally in horticultural crops. And HUSK is EBC certified and has received the C-Sync certification, meaning that they can trade carbon removal credits, and this allows them to sell the biochar at a price that is actually affordable for farmers. Because I mean, if farmers had to actually pay the price, like unsubsidized, so to say, by the credits, these would be too expensive. So thanks to the removal credits, farmers have access to these fertilizers that actually, significantly improve the return on investment and farm profitability. So this is already happening in real life. And so now this is the bridge to Carbonfuture. So you need, to be able to generate and trade these credits, you need a platform like the backbone structure to track and generate credits and sell them. And this is what Carbonfuture provides. And maybe to give a quick step back, I keep going on about carbon removal and these credits, but maybe you're wondering, who is buying this or why is there an interest in this? So there's actually a growing interest in carbon removal credits, especially from companies that are looking to, at the moment everything is in the voluntary carbon market. Soon it would be probably in the regulated market as well, but carbon removals for now at least are only in the voluntary market. So these are private companies that want to make pledges to be either to reach net zero or be climate positive. And there's different initiatives like the Science-Based Targets Initiative, SBTI, that set out a roadmap of what companies need to achieve to actually become net zero or climate positive. And so to do this, what companies need to do is really, first of all, reduce their emissions as much as possible. But then there will always be either historic or residual emissions. And so those can be compensated for with carbon removals. And so then reaching either net zero or then becoming climate positive. And at the moment, again, like Claudia mentioned, it's a great presentation to have before mine. Biochar is currently the only net negative emission or carbon removal technology that is actually, being deployed and available at scale. And biochar, I do agree, is still kind of seen as the underdog or the ugly duckling in terms of net negative emissions technologies. Maybe because it's too straightforward, I don't know. Yeah, it is at the moment the only net negative emissions that is available to date. And so the only credits that can actually be generated today and are not commitment into the future, like some direct air capture companies that are being developed and will come, but in the future. And so it's very important to increase the awareness of biochar in the wider sector. And so we're quite actively involved in different groups. So also the European Biochar Initiative, AB, is really a great group to have to increase the awareness of biochar overall. Anyway, yes, so there is a growing market for carbon removal credits, but then there's the link missing between the projects and the buyers, and this is what Carbonfuture aims to provide. So we provide a platform and marketplace from covering the whole value chain. So we work from the biochar production to the carbon sink creation to all the way to the companies that want to compensate their emissions. So we oversee the full value chain with the credit tracking, the credit creation, and then management, and also publication on a public registry. And this is very important as well, because by having a public registry, it means that the credits cannot be double counted. And also we provide full traceability of all the credits that are generated. The platform that I mentioned, this is basically what it looks like for biochar. So we, like I said, we track the biochar, we know where the biochar is applied, and then from all this information, a credit is generated. And why this is absolutely crucial with biochar is, as you all know, biochar, you could still turn it into, for instance, barbecue briquettes. So if the credit is only generated where the biochar is produced, this doesn't really give a guarantee that the biochar is actually going to end up as a carbon sink. So this is why it's a strict requirement, also in terms of from the first certification side, to track the biochar all the way from its production until its end use. And like I said, we know exactly each credit, where it came from, where it ended up, and all the emissions that happen from the production to the end use are also accounted for and discounted. And yeah, this is basically how it works. So the biochar producer gets certified according to a third-party certification and a third-party verification. Again, this is very important to have independent parties doing these things, so that all the accounting is done properly and there's no misaligned incentives there. So the biochar producer gets a production certificate certifying how much carbon removal they can generate, and then the biochar end use is confirmed through a coupon that gives all the information of like where the biochar ends up. And with that information, a certificate can be created, which is then validated, and a credit is generated that can then be sold to a balancer, a company that wants to compensate their emissions. So this is how the cycle works with Carbonfuture. And you might be wondering who's asking or who wants to buy these credits. There's actually, a growing demand for these type of removal credits. We have sold, these are all companies that we've sold credits to so far. So you see like some quite large companies and corporations like Microsoft, PwC, or Swiss Re. All these companies are very interested in carbon removals. They want, the demand is growing, and also the demand in terms of credit quality is growing. So it's very important for them to have, when they buy a credit, that they know that it's fully validated and that it's completely transparent, and that what they buy is actually carbon removal that can also be completely auditable at any time. And this is what we aim to provide. And so to go back to the rice farmer, these type of removals that these companies buy help farmers become more profitable and make their whole system more a higher return on investment, and also reward them for their climate positive actions. So yeah, thank you. That was a brief overview.
Thank you very much, Berta. Questions?
Yes. Right, Berta, thanks a lot for that interesting contribution. My name is Hannes Etter. I'm working for Southpole, so I'm one of your happy customers of your platform. one of the questions that I would have, maybe this is too much in the carbon nerdy scope here. The one thing on the, maybe specifically on the rice project, and this relates a bit to the feedstock discussion, which is kind of one of the overarching topics here, is you mentioned that sometimes those husks are burned for energy production. And what I'm interested, especially on now transferring those insights to the European context, where a lot of biomass is actually currently burned for energy production, is have you quantified, or is it quantified somewhere, the amount of leakage that taking the biomass out of the energy production into the biomass production is generating? I understand that the project itself is leading to energy production again itself, but is there a delta between the energy that would have been produced from using the rice husk for in a boiler, for example, and the energy that it would be produced by the biochar production itself? That's one question. The other one that I have is the carbon credits that you're currently selling. I understand they are certified by the carbon as a C-Sync certificate. Are your customers currently using that for their net zero claims and commitments as well? Because that would bridge again the Carbonfuture or the C-Sync certification way and any ICROA related standards. Not sure if that's too nerdy. Maybe we focus on the first thing.
Yeah, no, that's interesting about the the diverting the biomass from electricity generation. I don't think, like we haven't looked at that ourselves. I don't know of any study that has, but that would be interesting to look into. I mean, what I find interesting about biochar production versus electricity generation is that at least with by producing biochar, you're not fully taking the biomass out of the natural like soil cycle system. You're actually, you can actually put back some positive elements into soil and improve soil health. Whereas if you're only generating electricity, you're also taking away from the food system. So I think it would need to be the study would need to make a balance between the two, right? Taking away from the electricity, but also taking away from soil health and soil productivity, but would be super interesting to see. And the other question about the net zero, yes, that's an interesting one. I am, with the ICROA certification and all that. I know with CSI, they're going to be applying for a ICROA approval as well very soon. But I'm still fairly new to the whole carbon markets thing, so maybe we can discuss later. Yeah.
My name is Yanis Veneri from the Swiss Federal Materials Research Labs, and I have a question also regarding the sinks. Do you have a certain requirement for the duration of the removal of the carbon from the atmosphere? And does that allow any other type of sink than just putting it into the soil as soil improvement? I was thinking, for example, there was the example of using a biochar in concrete, but we're not exactly sure what will happen to the concrete at the end of the building's lifetime. And I was wondering how you account for that, for example.
Yeah, so we don't do the calculation ourselves. So we do what the certification or the methodology says. So the CSI EBC C-Sync certification gives a certification for 100 years carbon removal. And so this can, the final application can be in soil, also in construction materials, like in concrete. The thinking behind the concrete is that often, it will stay for at least 100 years as a building generally, or concrete is also often recycled. So that, I mean, the carbon itself is in the matrix and it can't leave this this matrix, like it wouldn't be emitted back into as CO2.
Berta, thanks for the nice presentation. I just have a simple question. It's the second time we mentioned this underdog status of biochar. So the simple question is how to get rid of it.
Yeah, it's an excellent question that we're actively trying to to address and even campaign for. So yeah, we're getting involved in like different groups of carbon removal groups, and also actually with the EBI we have this plan to also make a white paper just on biochar stability to once and for all address all the perceived unknowns on biochar stability and durability. I think one of the unfortunate things is that because it comes from biogenic material, it's often mixed in with other types of removals that are not as permanent, and there is not a good understanding currently on what biochar is and why it is permanent. Yeah, it's a ongoing battle.
Question we can answer this quickly, I guess. We have online questions.
Yes, thank you, Leo. Berta, can you say something about the financial model? How much money do the producing companies usually generate with their certificate?
The producing okay. Yes, so currently, the producing companies generate generally like at least 75 euros per ton of CO2. This is our current base price, but then depending on the price that the final credit is sold at, there is also like a share of revenue with the producers. But I would say as a baseline price, at least 75 euros per ton of CO2 equivalent.
Any more questions online? Nope. Then Nico had another question in the back. Nope. Then one here in the front. To your left.
Yeah, thank you very much for the very interesting presentation. My question would be regarding the demand of the rice husk biochar, because my name is Finn Stark. I'm from the city of Krefeld, and we are also thinking about like converting all the prunings, and like we're responsible for all the trees in the city and so on. So we've been talking a lot about the supply of biochar, and it's a really cool and interesting thing. But my big question is, like, every time I speak about biochar in Krefeld, it's like, yeah, what do you do with it? Like barbecue? Like, how is did you take a look at the demand side as well in your research?
Yeah, maybe I can. Yeah, this is a key question with biochar and like the demand in terms of the farmers, for instance, and it's very much location dependent. Like for instance, in Cambodia, we like HUSK is quite lucky in that because there is like traditional knowledge of biochar and biochar use, it's nothing that is new for them. So that's the entry point there it was a lot easier. But I think a key thing is, I guess like with any product, like understanding what farmers need and want, and maybe biochar on its own is not something that they're familiar with or that they know that well. But then if you mix it with then a soil amendment that they already use, and then it's like improved, and they don't need to change their current practices, and they see an effect on their yields, then that's possibly an easier entry point for them.
Okay. Christoph Thomsen, a question about like cutting methane by 50%. It is quite a game changer, I think. Could you turn that also into carbon credits and sell it? Question number one. And number two, do you think there will be similar effects when applying biochar in wetlands in Germany? Because there are also a lot of methane emissions from that.
Yeah. In terms of the credits, yeah, you could possibly, but again, I'm not an expert there. Maybe best speak to a Southpole guy. Who, sorry, yeah, these would be more like avoidance credits, not removal credits. So there would be different, it's a different market. So yeah, the offset market and the removals market are quite or are separate. But yeah, possibly like if you can measure and prove that there's by using a biochar, there's less methane emissions. Yeah, you can probably have avoidance credits. And your second question, I forgot now. Yes, with the wetlands, sorry, yes. Yeah, that would be, I imagine it could. I don't have experience myself. It would be super interesting to see data on that or research being carried out on that. But I imagine, I mean, any system that is like anaerobic, possibly adding biochar would have this effect. But this is more of an intuition than fact.
Stimme auf. Felix Ettel, Circular Carbon. I have actually an answer to Befel first. The best would be if you're from a city to use it as urban trees. So I think that would be a really strong argument. And in Stockholm, for example, they need about 1,000 to 1,500 tons a year just for the urban trees. Then another question to you, Berta. Thanks for your presentation. What would the farmers pay for husk products in Cambodia? Are they willing to pay a price? Because that's very often a challenging aspect.
Yeah, no, they are willing to pay a price. To be honest, I don't know off the top of my head, but it was basically the price without the removal credits, which was the situation. I worked with HUSK for a few months before joining Carbonfuture. So the situation there was that the farmers, when we were giving them the product for free and they were using it, they could see the yield increase, but then they were like, oh, we can't afford this like at this price. But then really with the removal credits, then they were able to like lower the price of the soil amendments to like, yeah, reach more like the local level of the prices, which is ridiculously low compared to Europe. But I can't remember exactly the price point.
Okay, thank you. Our last question.
Yeah. Hello, Thomas Hoffmann, my name, from Biochar. Also, thank you from my side. One question regarding the project in Cambodia. You had, or did you experience any kind of corrosion on your unit? Because I mean, we're talking about rice husk and there's a lot of chlorine and potassium inside, and usually that's for any system operator like something challenging, to say it quite frankly. Yeah.
I wasn't directly involved myself, but I did hear of a few nightmare situations that happened, and like parts needing to be replaced, and yeah, corrosion was definitely a challenge. So again, when I was at HUSK, they were looking at upgrading their production systems and taking from the learning from their initial year of operation. They were definitely, for their next equipment and scale up, this is definitely something that they were taking into account. Because yeah, corrosion was definitely a challenge.